Hey everyone. So today I'm going to go through the first problem from the worksheet. I'm going to be really completist about it. I'll probably actually record a couple separate videos on it just so that I can show you a few different ways to solve it. Um, and with the way I'm thinking about grades right now, I'm going to sort of show you everything you could possibly be expected to know. So whereas you probably could technically solve this problem in 5 minutes, if not less, I might be spending a good bit more than that. So I don't know how many videos this will end up being, but this is probably only the first one. So in this one, I'm going to show you the basic setup for the problem. And then after this, we'll show you different ways of solving. So that'll be the videos after this section. Do be in mind, keep in mind, everything I say in this video is something I could ask you. It's something I expect you to know and know how to do. Um, I think I'm only asking you to do 4 more things this entire year. That's why I'm pretty completist about those 4 things. All right, so let's go ahead and take a moment and look at the problem. A metal sphere is launched with an initial velocity of 1.5 meters per second as it leaves the ramp. The end of the ramp is 1.3 meters above the floor. Calculate the range of the sphere. So to start things off, I would expect you to read something like this to be able to pick out what all these numbers mean, what all these numbers are, figure out what numbers we're missing. I'd also expect you to be able to graph all this. So here's what I'm going to do, is I'm going to actually go ahead and start making a horizontal and vertical table. Oops. There, we'll use a nice straight line, shall we? So, whoa, whoa. Why are you not? Sorry, I'm trying to be. Woo. It's because I'm using a weird uh, brush. Sorry, guys. You probably don't want to sit here and watch me do this for 10 minutes. Anyhow, this will all be horizontal stuff, and this will all be vertical stuff. So we're going to split it up that way, which is something we've done in the past. But I'm actually going to start off by looking at just these numbers. So this 1.5 meters per second as it leaves the ramp, this is actually partially horizontal. Some of that 1.5 is horizontal. Some of that 1.5 is vertical. So we will have to split that up. Now looking at this triangle right here, how are we going to split that up? Well, the sine part of the triangle is this side. So that'll be the sine of the angle. And the cosine of the triangle is this side. So that'll be the cosine of the angle. So we then can tell that the initial velocity in the x, horizontal, is 1.5 meters per second times sine 20. And the initial velocity in the y will be 1.5 meters per second times cosine of 20. All right, let's pick up over here. 1.3 meters above the floor. Well, above, that's vertical, right? So that's going to be over here. Now, is that where it starts or is that where it ends? Well, it starts off here 1.3 meters above the floor. So that's the initial position in the y. All right, so what else could possibly we know? Well, we can name this position horizontally, whatever we want. I'm going to call it 0. So let's go ahead and say that horizontally it starts off at 0 meters. Let's think what else we could possibly know. Do we know the final position? Well, yeah, it's going to hit the floor. And so if it's up here at 1.3 meters, when it hits the floor, it'll be down here at 0 meters. So now our position is 0 meters. Now we don't know our final position. In fact, that's what the problem's actually going to ask us for, is what the final position actually is. The only other thing I think we need to know is acceleration and time. So acceleration in the y, well, it's free fall, -10 meters per second squared. There is no acceleration horizontally. I mean, unless there's air resistance or wind or something, I don't see any reason for that. So I'm not going to worry about that. Now, the time, we don't know. So I'm going to leave, if I can spell time, let her watch this. Sorry. All right, I'm a little out of it. Give me a second. Time. Right, so we don't know the time yet. That's probably something we're going to have to find. So one of the things I'm going to expect to be able to do is to pick all these numbers out of a problem like this. Notice not all these numbers are given. I didn't give you the -10. I didn't give you the zeros. You had to figure that out for yourself. That's something I expect you to be able to do. I would expect you to be able to pick out all of these numbers from this problem. I would expect you to be able to pick out how to split up the initial velocity. It always sort of works the same way, but that is something I expect you to be able to do. I'm going to go a little bit further here, though. So normally I would just go through and start solving the problem right now, but there's other things I could want. So I'm just going to make sure and be really completist and show you what the graphs would look like. So we're going to do 3 different graphs. We're going to do a position versus time graph. Let's switch over to a different marker for the... Sorry, one second. All right, I want to draw lines, and I need a marker that'll let me draw lines. So a position versus time graph. A velocity versus time graph. Oops. And an acceleration versus time graph. Well, look, I'll draw one for you, but it's going to be really boring for both of them. So the horizontal acceleration and the vertical acceleration. All right, these are graphs I would expect you to be able to make. So let's go ahead and start sketching this out. I'm going to switch over to a new color to make sure it's easy to read. I'm also going to lower the size here a bit. So let's start off with the acceleration. The acceleration is going to be the easiest one to do because they're both really simple. This is in free fall, and because it's a free fall, the acceleration is constant here at -10 meters per second squared. So the whole time we're going to get that acceleration. On the x-axis, horizontally, it's even simpler. There's nothing accelerating it. It's just going to be a nice constant 0 acceleration. So I wouldn't expect to see anything there. Now, velocity-wise, this is going to get a little bit trickier. We know that we start off with a velocity, right? I don't know exactly what it is, but it's 1.5 times 1.5 times the cosine of 20. So looking here, whatever that initial velocity is, that's a positive velocity. Now, why is it positive? Because if I look here at the problem, I have an upward velocity to start, remember? So that upward velocity to start is a positive velocity, but it's not going to stay positive because it's only going to travel upwards for a little bit, and then it's going to start falling downwards. And interestingly enough, we know that it's going to fall further down than it went up. In fact, the last set of problems we did had nice symmetric motions. This one's not symmetric here. It starts off at a higher level than it ends up, so we can't use our symmetry stuff for this. All right. Now, horizontally, we get something simpler. So horizontally, the velocity is going to start off at this positive value. I don't remember what it is, but it's just going to stay there. So this positive 1.5 cosine, oh, I swapped them. Sorry, guys. Swap these. My bad. This should be cosine. So sine is up and down. Cosine is left and right. My bad. So so we know the values of those two velocities. The horizontal velocity is not going to change. It's going to be the same the whole time. Vertical velocity will be changing. Now, as far as the position goes, remember position-wise, it starts off here at 0. That's the end of the ramp, and it's going to end up away from the ramp. Now, we don't know how far it's going to go. That's actually what we're looking for. Vertically, we know that it starts off above the ramp, 1.3 meters above the ramp. And it's going to keep moving up for a moment, and then it's going to curve. Oops, see if I can draw this. It's going to move up for a moment. Oh boy, I can do better than that. It's all right. Try one more time. No, I gotta make sound effects when I draw. That helps, right? Actually, that kind of helped. Not great, but it'll do. So we're going to end up getting this parabolic shape right here. I would expect you to be able to know what these graphs look like. I'd also expect you to be able to make a motion map. So real quick, I'll just draw one. We know that this ball starts off with some amount of upward velocity and some amount of rightward velocity, which means a moment later, and you can see, you can kind of follow the arrows. This is where the next one should be, right? Well, here it doesn't have as much upward velocity, but it has all the same rightward velocity. So again, follow the arrows. Here, it doesn't have any upward velocity, but it still has the same rightward velocity. Follow the arrows. Here, it has all the same rightwards velocity, but now it has some downwards velocity. All the same rightwards velocity, more downwards velocity. All the same rightwards velocity, more downwards velocity. All the same rightwards velocity, more downwards velocity. So as far as a motion map goes, that kind of covers it. This would work for me. Now, you guys did have that great idea to mention that these are all the same, so I'm going to put those little tick marks on here. I think that's such a good idea. I'm going to steal it. I wouldn't mark you off for that, but maybe in the future. All right. I haven't shown you how to solve the problem. I've just shown you how to get it set up and how to start thinking about it. We will end up solving the problem in the next videos, but I'm going to cut it off for now. All the things that you see here, whether it's just reading the numbers and knowing what they are, knowing how to split things up, drawing all these graphs, making a motion map, these are all things I expect you to be able to do. All right, everyone, as always, let me know if you have any questions. You can go through email, Classroom, or I'll be in and out of the Discord. Look for the next video where I actually start going through different ways to solve this. All right, everyone, thank you. Have a nice day.